Hello everyone. Today we're going to be looking at peripheral nerve damage, which is supposed to be one of the easier topics in MBBS, or at least the in my country. So peripheral nerve damage is quite frequently a topic that we kind of put off till the end of the day. So this video is mainly for those guys who want to just look this over before the Viva or something. And if you're scared that this topic is going to just show up on the exam, I'm just going to take you through the whole topic very quickly. Today's video is going to be kind of a shorter one because I'm trying to change up how the video and everything is structured. So yeah, let's just get into it as quickly as possible. Wait 1 second, let me just set everything up. Yeah, okay. So now again, first we look at the terms as is pretty much obvious on this channel. Uh, so the term chronaxy. Now to explain chronaxy, I'm going to first explain to you guys about the Rio base, right? Rio base is the minimum strength of stimulus that is required to elicit a biological response. The minimum stimulus you give to a nerve so that it shows some kind of stimulus is the Rio base. It's quite a simple answer, right? So Rio base is so all these terms, I'm just going to clear this up right now. So most of these terms will be used when we look at the strength duration curve, which is also quite a common question. So the applications of each of these terms we are going to look at then. But for right now, just remember that Rio base is the strength, right? It's the strength of stimulus that is required to elicit a biological response, the minimum strength, yes? Chronaxy is the time. Okay, actually, before I even explain chronaxy, I should just tell you utilization time because you'll get that why in a second. Utilization time is basically the amount of time taken by a stimulus of the strength of Rio base to elicit a biological response. So basically, the amount of time that a Rio base will take to show the response is the utilization time. Now, what is chronaxy, right? So chronaxy is basically when there's a stimulus that is of twice the strength of a Rio base, right? Twice the strength. Uh, Now that is going to elicit a biological response. So the time period in which that twice strong as Rio based stimulus is going to show the response is known as chronaxy, right? So now let's just look at the denervation hypersensitivity. So basically what denervation hypersensitivity means is that when a nerve gets damaged, then the receptors, the post nerve ending receptors, are going to be upregulated so that even like a very small amount of neurotransmitter passage is going to show a very high response, which is basically denervation hypersensitivity. So it's a physiological coping mechanism, we can say. So let's look at the causes of damage. Now, there's a lot of causes of damage. I'm just going to take you through roughly four of them. So there can be mechanical damage. There can be nutritional deficiencies like vitamin B12 deficiencies. There can be lack of blood flow due to some sort of vasculitis or something. There can be a tumor that occludes or presses or a tumor of the nerve itself that can cause these kind of damages. So these are just some basic causes of damage. If you had to write about them, there can be a lot. Like anything imaginable can kind of damage a nerve, like disorders like HIV/AIDS, diabetes. All of them will show some amounts of nerve damage, right? So now let's just look at the nerve injury classifications kind of. This is the main point that's normally asked in the various vivas and everything that are taken in the med colleges and stuff. So pay some amounts of attention because I also have a bonus classification that I found a lot of people don't know, but you should. Okay, so there's a second classification. There's the standard classification, which basically has three parts, which can be memorized by Nan, right? Nan, I think it means grandma, if I'm not wrong. But yeah, NAN. Neuropraxia, axonotmesis, and neurotmesis. Now, the spellings might be a little complicated, but trust me, the terms are not. Neuropraxia is basically when the nerve is getting crunched, you're pressing the nerve, or the blood flow to the nerve is occluded somehow. It's like a temporary amount of nerve damage which can be corrected, say, in a few hours or a few days, right? So it's not that tough nerve damage. Axonotmesis, on the other hand, is when the axon, or the central part of the nerve, gets quite severely damaged. So if the axons get damaged, then actually a term known as the Valerian degeneration will take place. Now, the Valerian degeneration is a separate beast, which we are going to tackle later in the video. So keep watching for that because it is quite important. So I'm sorry if you can hear some construction noises in the background, but I live next to like a area that's being constructed, so I really apologize if there's some problem with your experience. Okay, so we were in neurotmesis. Neurotmesis basically means like the axon has not only got damaged, but the surrounding connective tissue, like the anteneurium, perineurium, epineurium, these are basically coverings, which I'll take you through in a minute, will also get damaged. Now, I said that we're going to do like a bonus classification. So that's the Sunderland classification. Sunderland classification is normally taken up like during the MBBS lectures and stuff because it is quite a common type of nerve classification that's used. So I have like a little trick to kind of remember how the various forms are. So there are 5 stages of the Sunderland classification. So the first stage is, look at this. This is basically an artery. I'm very proud of myself for drawing this, by the way. Trust me, my drawing is not good. Even though I'm in med college, my drawing is horrible. But yeah. So let's just say this is blood supplying the nerve, right? So let's say this gets occluded. Okay, you know how neuropraxia works? Yeah, very similar to that. So that, my friends, will be the first stage of the Sunderland classification, the stage 1. Now the central one here is the axon, right? Now around, sorry, one second. So the central one here is the axon, okay? Uh, I hope you can see it. The one around it is the endoneurium, then there's the perineurium, and then there's the epineurium. Now, the actual nerve doesn't actually look like this. It looks very different. So if you want, you can check out the anatomy textbooks to see, because there's like sacculations and in which these endoneurium perineurium. So just for the concept of understanding, I've drawn it like this because you're going to understand it better this way. So this is the axon, the endoneurium, the perineurium, and the epineurium, right? So when axon gets damaged, now you have to understand that the nerve gets damaged from the inside out, kind of. So when the axon is getting damaged, that is the second stage. The endoneurium is the third, perineurium is fourth. Now it's a compounding. So in stage 2, there will be just the axon. In stage 3, it's the endoneurium and the axon. It's not like just the endoneurium is getting damaged. Both of them are going to get damaged, yeah? And stage 5 is just everything's gone. The epineurium, perineurium, endoneurium, and the axons all are gone. So that's the Sunderland classification. Those are the 5 stages. And relation to Sun is that the first one is very similar to neuropraxia. The second one again is similar to axonotmesis. So quite frequently you'll get asked a question: which stage of the Sunderland classification will the Valerian degeneration first take place? That's the second stage, right? Because we talked about axonotmesis, how it was the first stage where Valerian degeneration did take place. So second stage for Sunderland. Yeah. Now let's look at Valerian degeneration. Valerian degeneration is basically degeneration of the nerve fibers, which was named after a scientist. But we're not interested in scientists. We just want to know what it is. Spoken like a true student. But yeah. Uh, so Valerian degeneration takes place distal to the injury. Like there are changes that are taking place distal, there are changes that take place proximal to the injury. Distal means away, proximal means before. Uh, it's all in relation to where the thing has got injured. So for say for say my hand, and we're saying my hand got injured here, this is the distal part and this is the proximal part. Why? Because this is proximal because this is closer to my body. This is the distal because this is away from my body. Yeah. So distance the changes. The main changes in these kind of degeneration is actually taking place by the Schwann cells, which we all know are, we've studied in our the cells and the neurons, some of the cells in the neurons, which are basically responsible for myelination of the neurons. So what happens is that they undergo a change which will cause them from going from myelinating to demyelinating. So they'll start demyelinating the whole, what do you call it? The nerve. So, and this will cause the formation of ovoid because of the fragmentation of the uh, myelin sheath, right? Now, there's infiltration of leukocytes. Like with these kind of injuries, there has to be infiltration of the various leukocytes, and mediation is well, Valerian degeneration is basically mediated mainly by the calcium ion influx and the several changes that take place in the Schwann cell and everything. This is the main mediation. And some of the changes that are proximal is that the node of Ranvier node of Ranvier are basically in myelin sheaths. There are like tiny gaps from which there can be the jumping of impulse. The impulse doesn't actually jump, but we can kind of show it like that. So that's the node of Ranvier. So the first node of Ranvier that's proximal to the injury will disappear. And chromatolysis is the breakdown of the cell. The chromatic pigments will get broken down, and the cell body will become colored. That's why it says chromatolysis. Now, what are the associated physiological changes? Are basically that the receptors for the uh, post-nerve ending receptors will get upregulated because of denervation hypersensitivity, which we saw before. And okay, so now the strength duration curve, which is this. Okay, so the strength duration curve is very simple. This is the strength, this is the duration. So we've all seen like these terms, right? We're familiar with what the Rio base is. Rio base is here on the y-axis, which basically shows the strength. Okay, so before that, a lot of people have this confusion where they don't know what these two are. So this one is the nerve fiber that has been degraded or it's being damaged, and this one is the normal one. Now, why I'm going to tell you in a second. Notice how the Rio base is tiny for the first nerve fiber. Now, for a degraded one, it just doesn't say this in the book, but they do ask in the exams. This one will have a much higher Rio base, as is obvious because you can just pull a line from here. Now, this is the chronaxy, which is the duration is on the x-axis. So this is the chronaxy. This is the utilization time. You can see like the strength of an impulse is changing, but the height may be different, right? So the sorry, what I want to say is that the Rio base has literally doubled. So that's why on the y-axis is the same, but the chronaxy and the utilization time, there it's not exactly correct to say that the chronaxy is the exact half of the utilization time. That will depend on the slope of the graph. Since it's curved, it's not true, right? So uh, chronaxy will be less than the utilization time, but more than half the utilization time. Yes. So we saw the degraded nerve fiber. Okay, so these are basically the aspects that we will be seeing in the strength duration curve. Um, yeah, so this is quite basic stuff. It's not really that difficult. Uh, I would hope everyone is able to answer this stuff. Nerve regeneration. Now, nerve regeneration is kind of a little bit different. So, no, how nerve regeneration basically works is that it's mediated by the various Schwann cells that were causing the damage. Yeah, the damage was being caused because of the various various changes in the Schwann cells, which were taking place in order to repair the nerve fiber. So Yeah, my internet seems to be malfunctioning a little bit, so if this video is like a little bit buffered, I'm not really sure what's happening. I'm hoping everything gets fixed. Okay, I'm really sorry if there was some changes with how the video was working. I really don't know why it's happening. I'll look into it, but yeah. Uh, Maybe I'll talk a little bit slower. Maybe that will fix it. I hope. But anyway, uh, so regeneration is mediated by the Schwann cells. We saw that. Now the activation and the retrograde transport. Basically, the a lot of the nutrients and the growth factors and everything they'll get activated and they'll get transported retrogradely. That's what this point basically means. The RAGs are basically regeneration associated genes that get activated when there is a nerve fiber damage and Schwann cells form ovoids, the various changes that we saw in the Valerian degeneration. And the growth factors are basically the tumor, no, it's the transforming growth factor and transforming growth factor beta. That's the main one. And then there is nerve growth fiber, of nerve growth factor that's going to help the nerve grow into the various, when the nerve gets damaged, the basically a lot of fibers will be formed and then one fiber will go through in the exact same spot and then everything else degenerates and that one fiber will start getting myelinated and will replace the damaged nerve. That's how the basics of nerve fiber regeneration works. So that was basically it about this chapter. It's kind of a short one, I think, but yeah, it's quite important. I think my internet malfunctioned a little bit, but we move. Um, I hope you guys are enjoying these videos. Uh, it really means a lot to me if you could just like the video, subscribe, and just just leave a good comment or a good message. It might make someone's day. People go through tough days. I've been going through a weird day lately. It's been weird. I have made that sleep video, but you know I'm guilty of not practicing what I preach. I try to get enough sleep, but sometimes uh, I mean lay in bed and I just can't fall asleep for some reason. I don't know why it's happening, but whatever it is, I'm sure it's just a phase and will go away soon enough. Okay, thanks everyone. Thank you for listening. Thank you for your time.